Hello students, today we'll discuss about the topic equivalence class. In the last class we have discussed equivalence relation. So with the help of an example I'll try to explain what is equivalence class. Let R be a relation on set of integer z such that R equal to pair of ordered pairs collection such that A minus B is divisible by 3. We can prove this particular relation as equivalence relation. For proving, we can show that this relation is reflexive as well as symmetric as well as transitive. So this is an equivalence relation. Now let us consider this set. The elements which are related to 0. So collection of elements which are related to 0 are 0, plus minus 1, plus minus 3, plus minus 6, plus minus 9, and so on. So these are the integers which are related to 0. Next, 1, 1 plus 3 4, 2 plus 3 7, and this side 1 minus 3 minus 2, minus 2 minus 3 minus 5, and so on. The elements which are related to 2 are, we write like this: 2, 2 plus 3, 5, 5 plus 3, 8, and so on. And this side 2 minus 3 minus 1, minus 1 minus 3 minus 4, and so on. So these sets, these elements are related to each other. Here also elements related to each other. Here also elements related to each other, because 6 minus 3 is divisible by 3, 9 minus 3 is divisible by 3, 7 plus 2, 7 minus 2, that is 7 plus 2, 9 is divisible by 3. So if we take any two elements from here, their difference is divisible by 3. Same is the case here, also here. And if we take another set, the elements related to 3, then it starts with plus minus 3, plus minus 6, ... 0. That means it becomes the same set as us. So we don't have any more sets. So these three sets, if we unite, then we get the set Z. So these are called also partition of Z. It means disjoint subsets of Z. If we unite it, we get Z. So this is the meaning of partition of Z. Now this element here, this sets, in this set every element is related to each other, and we can also show that this itself is an equivalence relation. This is also the elements are related to each other these elements are also related to each other. These also elements are related to each other due to this equivalence relation. Now, these three sets are subset of Z, and these three sets are called equivalence class derived from Z due to the equivalence relation R. So now we will have the formal definition of equivalence relation. Given an arbitrary equivalence relation R on set of on any arbitrary set X, then R divides X into disjoint subsets called partition or subdivision satisfying number 1, all elements of AI is related to each other. Number 2, no elements of AI is related to AJ if I is not equal to J. And third one, union of AJ equal to X, where AI intersection AJ equal to phi if I is not equal to J. It means all the elements of AI is related to each other. No elements of AI, that means if we take I as 1, A1 element of A1 are not related to element of A2, or element of A2 is not related to element of A3. In the same way, element of A4 is not related to A5, etc. Now, union of all AIs is equal to X, the parent set, and intersection of AI intersection AJ is equal to empty set if I is not equal to J. Then these AIs are called equivalence class of X due to R. One more example, say RBA relation in Z such that R equal to collection of ordered pairs AB such that A minus B is divisible by say 4. We can take 5 to any number, so let us take 4. So due to this, we'll get 4 equivalence classes. They are 1, 0. The elements related to 0 are, we start with 0, comma plus minus 1, comma plus minus 4. We will go adding 4 plus minus 8, comma plus minus 12, comma dot, and the elements related to 1 are, we write here in the middle, say 1 plus 4, 5 plus 4, 9 plus 4, 13, and so on. And here also 1 minus 4 is minus 3 minus 4 is minus 7, and so on. So all the elements here are related to each other and also related to 1. And the elements related to 2 are, we'll write 2, then 2 plus 4 is 6, 6 plus 4 is 10, dot, and here again in the same way 2 minus 4 is minus 2, minus 2 minus 4 is minus 6, minus 6 minus 4 is minus 10, and so here, since divisible by, so we'll have one more subset or equivalence class, that is due to 3, which are related to element 3 plus 4, 7 plus 4, 11 plus 4, 15, and so on. This side 3 minus 4 is minus 1, minus 1 minus 4 is minus 5, and so on. So this 4, and if we take the equivalence class due to 4, it will same as coincide with this one. So here we have got 4 equivalence class due to this equivalence relation.